Hello everybody, welcome to our channel. Well, in today's video we're going to solve just problems about statistics and analytical chemistry. Our previous video was about statistics and we have just covered the precision completely. So if you want you can watch that video too. Well, here we have the first example. It says that two different students came up with two different data sets for measuring concentration of Mn in a sample. Real value is equal to 0.51. Whose precision is more, A or B? Here you can, if you want actually, you can pause the video and answer the question yourself and then we'll check it together. So let's do it. We can use many ways to answer this question, and each has its special pros and cons. Well, the first one is range. It's pros. So it's easy to calculate and gives us a quick sense of the spread. And the cons, it can be influenced heavily by outlier or extreme values, so it may not always represent typical variability. And you should care about this point, but it's so easy to calculate. And for doing that, so we need the step 1, which is calculating range for A, and step 2, calculating the range for B, and step 3, comparing these two. The lower, the better. So the lower range gives us actually has more precision. So here, as you see, we have solved it, and A is more precise because it gives us the lower amount. It gave us the lower amount. Well, the second point, mean deviation. What is the pros? Well, it's less affected by extreme values than the range, and it's simpler to calculate than actually standard deviation. What about cons? It doesn't take into account the squared deviations, so it may not be as sensitive to larger deviations as the standard deviation would be. It's something between range and standard deviation, actually. It's less complicated than standard deviation, but more complicated than actually range. And it's something but in between. Here you see, again, step 1 is calculating the mean deviation for A and B, and step 2 is just comparing these two values. The lower again, the better. So here you see I have calculated the value for both, but something to just tell you, for student B, I think the mean value is not 0.49, so instead you should use 0.51, for student B. You should minus every just data to 0.51, so care about it, and I think that's not true here. Well, as you saw, A is more precise because it gave us the lower amount. So this third way for solving this question is standard deviation. Well, the pros, it gives us more accurate results, and cons, it's time consuming and it's hard to calculate a little bit. So again, step 1 is finding standard deviation for each, and step 2 is just comparing the results. Here you see I have just calculated standard deviation for both, and as you see, A is by far lower than B, so it's just more precise, as you see. Well, the second example that we're going to talk about, we are considering two candidates for a laboratory technician position. Both candidates have experimented and recorded their data. So candidate 1 recorded the following value in milligrams: 34, 34.5, 34.7, 34.8, and 34.9. 5 values. Well, candidate 2 recorded the following values in grams: 0.7, 0.75, 0.8, and 0.6. 4 values. So we want to assess which candidate shows better consistency in their measurements. How to do it? You have again time, you can pause the video and answer it yourself and then check it with us. Again, we can use many ways to answer this question. Each has its special pros and cons. Relative mean deviation, RMD. So pros, simple to calculate, less influenced by outliers. Cons, less informative and less accurate. Well, of course, standard deviation is just so accurate, and other things that we might use are a little bit less accurate, or they give us less accurate results, so you should care about it. So here we have the answer for it for person A. Relative mean deviation is equal to mean deviation on mean. So why do we use relative mean deviation? Why don't we use just mean deviation? Because when we have relative, it's just unit free, it's dimension free, so you don't have milligram. When you have two different values and data sets with different magnitude, one is in milligram, the other is in kilogram, so it's not true to just compare them with just simple mean deviation. You must use relative form. Why? Because it's unit free. We have mean deviation and actually the units will be omitted in this form, so it's better to use. And as you see, we calculated it and we use it as a percentage. We found it in a percentage, so 0.763 is for person A, and for person B it's 8.8%, so it's by far again more. So who's more accurate here? Person A. The lower the better. So relative standard deviation. Pros, well, it's more accurate. What do you need more? And cons, it's time consuming again, and it's a little bit harder to just calculate it. Well, again, these steps. First, the value for the standard deviation for each should be found. And as you see, I have just calculated them. And something in here, actually, we shouldn't just divide them in 5. 5 minus 1. I have forgotten to do it, so just please care about it. And try not to do the same, make the same mistake that I've done. Here again, we don't have 4. We shouldn't divide them in 4, but 4 minus 1, actually 3, because we are using the sample form. Why? Because the number of our values are just lower than 20. So here we see. Now we should compare them. So the first one is 0.0, actually 9. Here we just divided the answers to the mean percentage, and actually the results are a little bit just not accurate because our standard deviation isn't accurate. And yeah, you can see it. Then we compare them. You should just compare them and find the answer. Well, thank you for watching the video, and if you liked it, you can click the like button, and if you just want to watch more, you can subscribe us. And if you want to talk with us or ask questions, just feel free to send us email. And that's all. Goodbye. Take care.